Let's chit chat for just a second. Okay. So here you guys are. What, Thursday? Got to take this test. Okay. You're going to get a question that you're going to have to try to figure out. One, is it confidence intervals or is it hypothesis test? Is it one sample? Is it two sample? Possibly, is it matched pairs? It won't be matched pairs. I'm just telling you, it will not be a matched pairs test. Okay. So that's your choice. Okay. You're going to have a free response question like one of those two. Okay. After doing this yesterday to, was it third hour? I don't think I can get two of those in time. These take a little longer just because it's all the writing and just doing the complete thing. Remember on May whatever, when you're taking this AP test, right? You're going to have 6 free response questions. 6 of them, right? You get an hour and a half to do all 6 of them. You get 90 minutes to do all 6 of them. That comes up to about, evenly, I guess it comes up, what, 15 or 16. But number 6 is going to take you a longer time for sure. No question. You haven't seen the number 6 yet. It's always A, B, C, D, E, F, G. It's a long one. They expect you to take about 25 to 30 minutes just for number 6. So that comes up to about 13 minutes per question. Some of them you'll do quicker than 13 minutes. Some of these may take a little bit longer than 13 minutes. Just kind of understand all that. You get all 6 questions, so you can do however long it takes. If it takes an hour and a half to do one of them, then whatever. Y'all okay with that? Now, you don't have that kind of opportunity Thursday because you're getting 2 or 3 free response questions, right? 2 or 3 free response questions, and you're getting 20 multiple choice questions, but I give them all to you at one time, right? Just kind of remember these type of things. Just kind of put yourself in that situation. So one of your free response questions is going to be a full-blown, is there convincing evidence or construct and interpret? One of those 2 questions, right? So if there's convincing evidence, you know it's going to be a hypothesis test, and you got to recognize, is it one sample or is it 2 samples? Construct and interpret a confidence interval. Well, that's a confidence interval, and then you got to decide on if it's 1 sample or 2 samples. Okay. Somebody asked me earlier, can I do a confidence intervals with a hypothesis test? You can if it's two-sided, if it's two-tailed, if it's not equal to. You can, but you still have to do the ho and the ha. You still have to reject or fail to reject. And one of the toughest things that students forget to do is tell me what alpha is. Because if you do a 95% confidence interval, then alpha is 0.05. If you do a 90% confidence interval, then alpha is 0.1. And if they tell you what alpha is, then they're telling you what level to use, all those kinds of things. But if it's one-tailed, it's hard to do a confidence interval with a one-tailed because it's just the right tail. So that changes up things a lot, okay, with all that stuff, right? Also, AP grades differently than I do, right? AP is going to give you an E, P, or I. I pretty much look and see what it takes to get an E. If it takes 3 things to get an E, then I make it 3 points. Sometimes 4 points, and just give you a point for getting close. Okay, with all that kind of stuff. But in AP, if it takes 3, then that takes 3 to get an E. If you miss any one of those 3, it drops to a P. Well, that's pretty harsh to me, considering it's, basically you get 3 choices. This is like 0 points. This is like half points, and this is like a whole point. So that's kind of why I do 4 points. I'll give you 1 point for just knowing something about those. And then if you miss one of them, well, it just drops you to 3 out of the 4 or 2 out of the 3. Just kind of understand those type of things the way that I do it, a little bit different than the way AP does it. Your job is to try to get as many of these as you can. But if you can't get one of those, then you want to try to get one of these because these don't count for anything. Those don't count any points, right? So you're trying to get as many points as you can. This one, number 10, chapter 10 first. Okay, chapter 10 first. So kind of go through it, look at the rubric. As I go over the rubric, look to see if you get those points or not. Okay, it does not have to be in the order that they are. You'll see that their rubric goes in a little bit different order than the way that I do these, which is probably going to be different than the way you do them because you're going to do them kind of like I do them. They don't really care where this stuff is. They just want to see it. So here is chapter 10 FRAPPY rubric. So everybody just kind of focus along. Here's what the intent of the question is, which again, you don't really care what the intent of the question is. Here's the model solution. Okay, I don't care about the model solution yet. We care about how we're going to get the points. So that's the model solution. Nobody ever looks like the model solution. Nobody, right? Scoring. Okay, this is important. This question is scored in 4 sections. So they broke this up into 4 sections. That's a pretty common thing for them to do, is break things up into 4 sections. Sometimes it's 3 sections. Sometimes it's 2 sections. This question, 4 sections. Section 1 consists of step 1. Section 2 consists of step 2. Section 3 consists of step 3. And section 4 consists of part B. Okay with that? So they broke A up into 3 different sections, and then part B is the 4th section. That's kind of, again, the way they did that. So picture me grading this. I'm looking at this rubric. This is when I start grading a whole lot more like the rubric than I do what I think should be, right? So I'm looking at 4 different sections on your paper. Of course, B is its own section. So that's going to get its own EP or I, which is probably 4 points the way that I would do it, right? And then section 3, probably 4 points, 4 points, 4 points. Okay, that's kind of the way I do those. So here's how you're going to get an E for section 1. Essentially correct that the response includes the following 3 components. So we got to have all 3 of these to get an E. Identifies a 2-sample T interval for a difference in means either by name or formula. Either by name or formula. Now there are a couple of notes here later on. Here's component 1. So this is component 1. I'll go ahead and give you that note. It is not satisfied if the response states that the procedure is a 2-sample Z interval. So if you say Z, that doesn't fit that. Well, I mean, we kind of understand that. If you mention anything about Z's with means, you're done. You're not going to get points. You got to talk about T's with means, Z's with proportions. Okay? I think that's it about, here's section 1. All right, that's all right. Notes that a random assignment was used to determine which students were given the quarter sheet and which were given the 6th sheet. Notes that random assignment. So basically random assignment. And then you would like to branch that off with so-and-so get this and so-and-so get that. Notes that both sample sizes are large by comparing each sample size to a boundary such as n is greater than 30. I don't know what other boundary there is other than n is greater than 30. Okay, so 3 points. I'm looking at 4 points. I might split this up into 2 different ones or whatever, but that's kind of how I'm looking at it. Now, most of you guys, at least if you're like me, I don't identify the 2 sample. I don't identify the name or formula until the work. That's where I identify it. They don't care where you do it, as long as it gets done. They didn't say anything about the 10%, and they're not supposed to because it was a assignment. Do note that here, P. So P if you hit 2 out of these 3. P if you hit 2 out of these 3. I otherwise. Now here's those notes, okay? To adequately address the random condition, the response must include random assignment. It must include random assignment or equivalent, which I don't know what else you can do equivalent-wise. If a response states the random sample condition is SRS check or random samples given, it's not satisfied. You're not going to get it for an SRS because it was not an SRS. You're lying, right? We talk about all the time. Don't lie. Don't lie. If the response include wrong statements about the conditions or additional inappropriate conditions, such as n times p is greater than 10, which I don't know how you can do n times p is greater than 10 because it wasn't proportions. But apparently students do that because they're talking about this being inappropriate. Or if the sample is less than 10% of the population, because Jessica didn't sample without replacement from a population, or an incorrect statement about conditions such as large sample sizes implying the population normality, then the response can earn at most a P. Like there's no way to get an E if you did one of those things. Y'all okay? Because you can't do those. It's not what that is. Any statement of hypotheses. If a student happens to do a hypothesis or definition of parameters, should be considered extraneous. However, if such statements are included and incorrect, by doing a parameter as a sample or yada, 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 or talking about 46 and 45, they are considered poor communications in terms of holistic grading. So they're not going to ding you yet, but they're going to look at the entire thing, and if you end up with those half points, they're going to ding you enough to drop you down. Y'all kind of okay with that stuff. I don't expect us, I mean, just by as many times as we do these type of things, to make these kind of mistakes, because you guys are freaking brilliant. But understand that happens. Any questions about those three? Any questions about those three? Part 2. This one's kind of rare for me. E, if the response gives the correct 95% confidence interval, supporting work is not required. But if it's included, it better be correct. Y'all kind of okay with that? I'm not, but they don't care about any work. They want the confidence interval and they want it correct. And if you got it correct and you don't have anything else, section 2's an E. Partially correct of the response gives the correct confidence interval with incorrect but appropriate supporting work shown. So this is where you can kind of get dinged by maybe putting too much. Kind of follow what I'm saying. You may have wrote the wrong formula. You may have put the wrong value in the formula. You may have told me what T was, the T critical value, but it was the wrong T critical value. You're going to get dinged for all those things if they're wrong. If they're right, you're okay. So here's my quick recommendation to you. This is going out to everybody because I'm recording all this stuff. If you're concerned about doing something wrong, don't put it. Don't put it. You're better off leaving things off than putting things wrong, because putting things wrong are wrong. Leaving off, you probably did it right. You hope to hit it. Y'all okay? I kept talking all the times about you better put DF, you better put DF, you better put DF. There was one rubric that said student must identify the degrees of freedom. This one didn't say that. Good? If the response gives an incorrect confidence interval with appropriate supporting work, for instance, if an incorrect value is used for the critical value or the standard deviation is not squared, that's a partially correct. These are both partially corrects. So you got the incorrect interval, but everything you put was correct. You just did one of those values for wrong reason or another. If you got the correct interval and these are wrong, that's bad. If you got the incorrect and these are wrong, that's bad. If you got the correct interval and you don't have any of this crap, it's good. That kind of goes against what we've talked about all year long, is never have a naked answer, right? The correct interval, just to make sure, like I said, very seldom do students get that wrong. Negative 1.879, equivalent. It doesn't have to be exactly that, but close, and 4.679. And my guess is that's the answers from the calculator, that if you punch everything up correctly, it's going to give it to you just like that. Here's where they wrote the formula. If you did that, you're good. Here's where they put some values. You're good. There's the T critical value with DF being 92.9. I think it was actually 92.88 something, right? If you put all that stuff, it's good. But if any of this is different, whoa, wow. But the confidence interval, oh, it didn't go as far as I did. But that's correct, you're going to get dinged. You'll get dinged if you didn't square these things, but you got that right. If you did put some other thing, I don't know what else you put. If you put the wrong DF, if you use what, 45, you get dinged because that doesn't fit the 45 DF, that fits the 92 DF. Any questions about all that stuff? Hit me. You don't have to for this one, according to the rubric. Will I grade for it? Probably, right? Because I got to get 3 points somehow. I got to get 3 points somehow. If you get the right interval, that's going to be at least 2 out of the 3, or if it's 4.3 out of the 4. Right? And I'm just looking for some other kind of supporting work, just like I would do back in pre-cal days or algebra 2 days. Right? If you get the right answer and you got something verifying it, now if you get the wrong answer and you got verifying it, that's going to depend on how many points you get correct. Who's calling me? Everybody I know's here. What? Hello.
Hi, can I get Ariana Gomez for checkout, please?
She's gone. No, I'm sending her. I'm sorry. Bye. Check out through the front desk, please. Okay. And so that's part two. Oh, that's section two. Incorrect if it's not, okay? And then here's some notes on all this stuff. There's telling you here's what the confidence interval is if you used a different DFs. Just because that might happen. I can't imagine anybody in this classroom having a different DF other than the one that they gave us. Okay? So, note a response that uses DF of 98, a pooled 2 sample. Well, we told you not to ever use pooled, so don't do it. Okay? So, section 3. Here's section 3. Essentially correct if it provides an appropriate interpretation of that interval that includes the following 3 components. So we got to have all 3 of these components. Uses the phrase 95% confident appropriately. i.g., we are 95% confident, or with 95% confidence. Describes a difference of means in context. You got to have those words, difference of means. And it has to be in the context. And then the interpretation is not about the groups of 46 and 54 because that's the sample. We can't talk about the sample. We can't reference the sample. For example, a response that describes a difference in means for the 2 groups. That's common. That's a common mistake. We are 95% confident that the difference between the 2 groups. That's bad. That's just referencing that sample. You got to make sure we reference the entire population. We are 95% confident that the true difference is between this and this. Just don't talk about the sample. Okay? Partially correct if you hit 2 or 3. 2 of the 3 components. Incorrect if you don't meet E or P. Here are some notes for this one. Okay, so let's talk about those notes. A response that includes an incorrect interval is not penalized for section 3. They don't penalize you if you mess up somewhere up here and you carry it through. All right, that's double dinging. To satisfy component 2, which one was 2? 2 was the difference of means in context. You must refer to a difference of means in context. You got to hit all 3 of those to get component 2. So that's like a 3 of the 3. When both interpretation of the interval and the interpretation of the confidence level, y'all remember the confidence level, if I did this over and over and over again, 95% of these intervals, that's the confidence level. So if by some reason you interpret it that way, only the interpretation of the interval is scored. If the interpretation of the level is incorrect, it's considered poor communication in terms of the holistic grading. So it's not going to be counted against you other than the holistic grading. And if it's holistic, it's going to bump you down, for sure. Any interpretation that implies the interval has a 95% chance is an I. Anything that we talk about a 95% chance, it's an I. Because that has nothing to do with a confidence interval. Okay? I've emphasized that several times. Just please be careful about that. So that's components 1, components 2, components 3. So basically that's part A. Part A. Okay? Part B is section 4. Part B. Essentially correct if the response includes the following 3 components. So we got to have all 3 of these things. Indicates that 0 is in the interval. States that there is not convincing evidence of a difference of means? There is not convincing evidence of a difference in the means, and we got to put it in context. You have to put it in context. Partially correct if you hit 2 or 3 of those, incorrect if you don't meet the E or the P. Now, they will say these things down here, okay? A response that states there isn't convincing evidence that the paper size affects the mean word count satisfies components 2 and 3. There isn't convincing evidence. If the response provides an interval that does not include 0, so by some crazy chance you missed the interval and it doesn't include 0, then I hope you reject. Right? Because that's the right answer according to your interval. They will not ding you for that because you already got dinged up above for the incorrect interval. And you should state there is convincing evidence that the paper size affects the mean word count because 0 is not in the interval. Responses that are equivalent to accepting the null do not satisfy component 2. You cannot accept. You cannot accept. We cannot say that it is true. All we can do is say we do not have enough evidence to say that the ha. Every E is counted as a 1. Every P is counted as a half. And then they're going to look at it holistically. And that's where, if you end up with one of those halves and you write down the formula with all those values, that will give you a little bit more ammo to bump you up. It's hard to bump 3.5s up to 4s. It's hard to bump halves down to 0s. Fair enough with all that stuff. Okay? And then we just got to consider, that's why I just make mine this point per point per point, and then I don't have to worry about bumping things up or bumping things down. So every free response question on AP is worth 4 points. It's worth 4 points. Your job is to try to get as many of those 4 as you can. All I's, 0 points. We don't want 0 points because there is a multiplier to it. Right? So 6 times 4 is 24. Well, the whole free response is worth 50 points because there's multipliers. We'll talk more about that when we get closer to test day. 10-4. Any questions about number 1? I saw a lot of people having some issues with some calculators. Make sure you get comfortable with those calculators, guys. You don't want to spend time doing things on calculators that you're not comfortable with. Do those worksheets that I gave you. There's 18 ways to practice with your calculator on that worksheet. Okay? Those are where you need to get practice with your calculators. Get comfortable with that thing. Because test day, I become pretty stupid with calculators. Because I'm not going to be there on AP test day. I'll be there in spirit, but I won't be there, right? I can't tell you what you can do. Now, sometimes I will help you out on this, but a lot of times I don't because I'm better off just not saying anything rather than, well, you helped her, you helped him. Yeah, okay, I'm okay with that, right? Any question about number 10? Any question about number 10? All right, let's look at number 11. Look at number 11. There's the model solution, model solution, model solution, model solution, model solution. Here's the concluders, model solution, scoring. Scoring, sections 1, 2, and 3 are scored as an E, P, or I. Or does it tell me that there's 3 sections? They didn't. It's just one question. That was just one question, right? So they broke it up into 3 sections. That's rare. Normally hypotheses are broken up into 4 sections. But they broke it up into 3 sections. Each section is scored at E, P, or I. That's pretty common. Again, sometimes they're scored just E's or I's. Sometimes. So here's how you're going to get the E for section 1. Section 1. Again, you probably do not have all this in a section, right? You guys are, I saw a lot of you guys putting up a big old plus sign. That's phenomenal, right? Hypotheses imply equality of means in the null and correct direction of the alternative, indicating that the mean percentage of popped kernels will be larger for the name brand than for the generic brand, somehow or another, right? So it's not a non-equals, it's a greater than or less than, okay? And depends on which one you put as mu1 and which one you put as mu2 is which way yours goes. It's okay to flip-flop all this stuff. You might have a greater than and you might have a less than, but your greater than and your less than better still equate to the same group. You can flip-flop all this stuff. It doesn't really matter. That's why you have to label it all. Both parameters are correctly identified as the mean percentage of popped kernels. The two-sample t-test for a difference of means is identified by name or formula. And I'll give you a hint. In the notes, two-samp t-test or equivalent is acceptable. So they didn't really care that you put the difference. They didn't really care that you put the word mean. That's one of those things that probably won't help you, but it's not going to bump you. So two-samp t-test, which is what your calculator says, which apparently is the way a lot of teachers teach them, they're not going to ding you for that. I like difference two-sample mean t-test. That just says a little bit more because that just verifies things. If you put int, you're dinged. That doesn't cover that. It's not an int, it's a test. Okay? What else do they talk about? If the hypotheses are stated in terms of sample statistics, component 2 is not satisfied. Duh. However, if the hypotheses are otherwise correct, component 1 is satisfied. So, component 1, talking about the equality and the greater than or less than, that's satisfied. But if you use X bars or P hats or P's, then it's not going to give you for component 2, which is basically you're defining mu sub 1 and mu sub 2. To satisfy component 2, the parameter definitions must be in context and must talk about the means and population. You must have the word mean and you must have population or true. Okay? Responses that describe sample means, the mean percentage of pop kernels in the 10 bags, do not satisfy component 2. Two-samp t-test is acceptable of naming the test. If the test is correctly identified by name, but then incorrect formula is stated, that is considered a parallel response, and component 3 is not satisfied. So if you did name and formula, your formula is wrong, but your name's right, you don't get the credit. You do not get the credit. So be careful about that stuff. They don't want you putting wrong things. Okay. A two-samp Z test for difference in means is not the correct test procedure because the population standard, so Z, again, Z, mentioning Z's is not correct. Not correct. All right, here's section 2. E, essentially correct if you hit 4 of the 5 components. That's a little interesting. They're going to give you some leeway. So you don't have to hit all 5 of these to get the E, but you got to hit 4 of them. My test, I'll have that worth 5 points. Okay? Notes that independent random samples of the name and store brand bags were selected. 2 independent random samples. Checks the 10% condition, independent observation, by noting there are at least 100 bags in the populations. You can say there's at least 100 bags in the populations. Or by noting that 10 is less than 10% of each. Right? You can state it one way, both ways. 10 is less than 10% of all. 10 is less percent of all. Okay? Checks normality of both populations. Checks normality for both populations. Reports the correct value of the test statistic. Reports a p-value. So they put all of that as 1. Normally they do split that up. Normally they split that up into basic, because they basically checked for the test statistic and the p-value. They added that, basically the conditions. Partially correct if you only hit 2 or 3. It's kind of weird. So you only hit 2 or 3, which I really hope that everybody hit at least the first 2. Those are like the conditions that we've said over and over and over and over again. My guess is you hit the first two and you probably got the last two. The normality, you got to draw the graph of those things. Okay. Let's look at some notes. There's several notes on this one. Okay, several notes. For component one, the response must indicate that 2 random samples were selected. In other words, random check is not sufficient. Random check is not sufficient. Independent is not required. But you got to mention 2 separate. Okay, you got to mention 2. So 2 SRSs would count. I like 2 independent resonators. For component 2, it is minimally accepted that 10 is less than 10% of the population size without specific reference to both samples. So we got to mention that 10% twice, or plural of everything. To satisfy component 3, responses must include reasonably correct graphs and include appropriate comment about the shape or outliers, such as there are no outliers in either distribution. The distributions are both roughly symmetric. It is obvious, no obvious departures from normality, approximately normal, etc. And that's where I've talked about several times of what you should be able to put or what you can put, and I really don't care at this point. I don't think large counts fits. Y'all kind of good? I mean, they don't say anything about large counts because it didn't fit the large counts. You had to graph it. So large counts will not help you. So no outliers. They both look roughly symmetric. It's no, you can't put normal. Normal will get you. You got to put that approx in front of it. If the response includes additional incorrect conditions, such as n times p is greater than 10, it's going to reduce the number of components by 1. So if you hit 5 of them, it's going to reduce it, and you're only going to hit 4 of them. If you only hit 2 of them, it's going to reduce it, and you're only going to hit 1 of them. But I can't imagine anybody saying n times p is greater than 10 because we don't even have any p's going on. Responses that use 2 sample Z test can satisfy component 4 and component 5. Correct standardized test statistic and p-value are provided, since the response has already lost credit for identifying the test in section 1. So you already got dinged for saying Z. You're going to get dinged. You're going to miss everything else. Again, I can't imagine anybody doing anything with Z's in this class, because this is one. I mean, everything's going to be T's in this test. A response that uses pooled. Well, we don't pool anything, so you don't have to worry about that. If the response did not satisfy component 1 in section 1 because the 2-sided alternative was stated or the direction of the alternative was incorrect, the p-value in component 4 should be consistent with the stated alternative. So if you miss the alternative, hope everything else fits, because you're not going to get dinged for it. If this is incorrect and this stuff is incorrect, then you will get dinged back. You'll miss both. If a response is a correct test statistic and or p-value but shows additional incorrect work, such as inappropriate formula, reduces the number of components by 1. You're better off leaving things off than putting things wrong. Let's go up and make sure. Here's the model. So let's make sure you got the right values. Okay. So there's their graphs. Okay. Way better graphs than I'm sure you guys put. Hopefully you put at least a little something with there. Okay. There's X bar. T 2.43. P-value 0.013. 0.013. DF should be 17.93. Should be. If DF is different and you got a p-value of this, you'll get dinged because you're lying. That only fits that DF. If you put the standard deviation in the formula, make sure you square them. You will get dinged. Questions? You don't have to draw a picture. Okay, here's section 3. Section 3, and y'all know what's coming, right? I hope. Essentially correct if you hit all three components. Explicitly compares p-value to the significance level. Compares it. Since p is whatever to alpha. I think it was less. Makes correct conclusion about the alternative hypotheses. There is not, or there is. I forgot which one it was. Was it less than? Less? So there is convincing evidence that there is a difference between, or not, no, that this is less than this. And the conclusion is stated in the context. Partially correct if you only hit 2 out of those 3. Incorrect. Here's some notes. If the conclusion is consistent with an incorrect p-value from 2, it's also, you get full marks for it. If your p-value is wrong, but your conclusion is correct with your wrong p, you're okay. You're not going to get double dinged. The conclusion must be about the mean percentage of popped kernels to satisfy component 3 unless the response has already lost credit in section 1 for neglecting to include the concept of mean. The conclusion must be consistent with the alternative hypotheses to satisfy component 3. In other words, if you got the wrong hypotheses, your conclusion better fit your alternative. A conclusion that's two-sided. We have convincing evidence that the mean is not the same, does not satisfy component 2. If an incorrect interpretation of the p-value is given, reduce the number of components. You didn't interpret the p-value, I'm sure. If you did interpret it and you interpret it wrong, it's going to ding you 1. So instead of getting all 3, you can only get 2, or instead of getting 2, you can only get 1. Here's how you get the points for this particular one. This is common. The only way to get a 4 is to get all 3 E's. The only way to get a 4 is all 3 E's. The only way to get a 3 is 2 E's and 1 P. That's the only way to get a 3. 2, there's several. 2 E's and no P's. 1 E and 1 or 2 P's. Or 3 P's. That gives you 2. And then 1 is either 1 E or no E's and 2 P's. So 1 P is a 0. 1 P is a 0. You got to have at least 2 P's to get 1. 3 P's get you a 2. Can't get 4 P's because there's only 3 sections. 1 E and 2 P's is still just a 2. 1 E and 1 or 2 P's. So 1 E and 2 P's and 3 P's are the same. And 2 E's and no P's. Kind of weird, but that's what they decided for that one. That changes from question to question. Who has anything? I know this is a little, you guys are trying to soak all this stuff up. You're trying to get as many points as you can. I do think that a lot of you guys try to put too much. I do think you try to put too much. We're trying to look at it holistically. Do you know how to do a confidence interval? Do you know how to do a hypothesis test? Forgetting to put the ho and aha, that's a big deal. But we also know that your calculator is going to do 90% of the work, and that's why most students don't get that stuff wrong, because the calculation part is okay. Talk to me, bro.
You said you were going to grade the DF on the test?
I don't know if I will or not. I have to look at that rubric is. Yeah, I mean, if you put it in, yeah. It can't hurt you to put it as long as you put it right. Fair enough? It's hard for me to take off for you forgetting to put it.